Section 6.6, Problem Solving Investigation, choose the best strategy. That's just a fancy code name for do what you want. Daisy made invitations on her computer for a party. She distributed 1/2 of the invitations while her friend gave out 16. There are 5 more invitations that need to be delivered. How many invitations were there to begin with? Step 1, understand. Be sure you understand the problem. What facts do you know? We know that Daisy distributed 1/2 of the informations. Daisy equals to 1/2 of, I'll use P because I looks a little bit like 1. And you usually don't use I for many different reasons. Like, I don't know. Get the joke? Anyhow, her friend gave out 16. And there are 5 more. What do we need to find? How many invitations were there to begin with? A good plan for this would be to work backwards. Say, since we know that 1/2 of the invitations plus 16 of the invitations plus 5 is equal to the total number of invitations, then we know that 16 plus 5 is equal to the other 1/2 of the invitations. Which means that 1/2 of the invitations is, well, 21. And if 1/2 of the invitations is 21, then the total number of invitations would be 21 times 2. And 21 times 2 is equal to 42. There were 42 invitations to begin with. Is the solution reasonable? And how can we check our answers? By working forward? Well, these two questions kind of go hand in hand. If you check your answer and it's, well, correct, then whether or not the solution is reasonable kind of doesn't really matter. I'm sure I've told you the story, and if I haven't, then, well, sometimes math problems can have absurd things such as 1,800 bananas, a person ate 120 candies in one sitting, yada yada yada, etc., etc. So yeah, reasonability isn't the topmost priority of some math problems. Therefore, as long as it's correct, you should be fine. Now, how do we work forward? 42 invitations. Daisy gave out 1/2, which means that Daisy gave out 21. There's 21 invitations left. And then Daisy's friend gave out 16 of them. 21 minus 16 equals to 5. There were 5 invitations left. There are 5 invitations left in our scenario, which means that our calculations are correct. Reread the problem to make sure you got all your facts straight. Daisy made invitations on her computer for a party. She distributed 1/2 of the invitations, while her friend gave out 16. There are 5 more invitations that need to be delivered. How many invitations were there to begin with? We answered the question and all of our facts were straight. Meaning that, well, our answer is correct. We also checked it through, which is also even better. The coach gives uniforms to 1 set of the players on a soccer team. Brad helps out, giving uniforms to 3 players. James gives the remaining uniforms to 5 players. How many players are on the soccer team? Okay, so basically, 3 players plus 5 players equals to 2/3 of the team. Because the coach gives out 1/3. And last time I checked, 1/3 plus 2/3 equals to 3/3, which is just 1. So if 8 is equal to 2/3 of the team, then 1/3 of the team would be equal to 8 divided by 2, which is 4. So the entire team would be 4 plus 8, which is, well, 12 people. Now, Leon is 1/3 as old as Carrie. So 3 Leon's age equals to Carrie. Carrie is 6 years older than Joy. So Carrie is Joy plus 6. Joy is 18 years old. How old is Leon? Well, we work with some algebra, so Joy is 18, which means that Carrie is 6 plus 18, which means that Carrie is 24. And if Carrie is 3 times as old as Leon, then 3 times Leon's age is 24. So Leon's age is 24 divided by 3, which is 8. Leon is 8 years old. I would never understand why the cursive letter S is written like this. Anyhow, continuing swiftly on, if you want to take a break between sections, go ahead. But if you don't, or you just came back, estimating products of fractions. Now here's the problem I have with the curriculum. Why would you teach estimation before how to do the thing first? Like, if you think about it, if you know how to do the thing, then you would usually know how to estimate the thing, as long as you know how to round. So why would you teach how to estimate the thing before how to do the thing? But okay, to estimate a fraction of a whole number or mixed number, you can round the whole number or mixed number to a multiple of the denominator. Here's the thing. It's basically telling you to go like, oh look, the denominator is 7. What are the multiples of 7 that are close to 32? Well, there's 35 and there's 28. 35 is closer. Therefore, we use 3/7, that's a 7 guys, not a 2, times 35 instead. My voice is cracking at sheer rage. Anyhow, why? Why? Just why? Okay, okay. Everything is good. And then, this is what they want you to do. 7, 5, reduce. Well, not 7, 5. 7, 35, but you reduce to 5. And then it's 5, 1. And then you get 3 times 5, which is 15. I don't know why anybody would want to do this. I mean, there's probably a reason. There's probably some semblance of reason. But still. Anyhow. 1/6, denominator is 6. Multiples of 6 that are close to 19 include 18. So then you estimate into this, and then you reduce, and then you get this 1 times 3 equals to 3. And you realize that, oh, 1/6 times 19 is approximately equal to 3. It's equal to just... We're learning about multiplication of fractions in the next section, which is right now one of the few things that is preventing me from completely raging at this, because even if you estimate, it wouldn't... I mean, this isn't the worst way to estimate, but usually with fractions, you just know. Anyhow, 61 and 5/12. Denominator is 12. Multiples of 12 that are close to 61 include 60. So that'd be 60 times 5 over 12, and then you cancel, well, not cancel, you reduce to simplify, and then you get 5 times 5 equals to 25. Therefore, this equation over here is approximately equal to 25. They're not wrong, but honestly, it's closer to 25.5. Not the worst estimate I've seen, though. Okay, 4 over 9 times 87. Now, 87. And the denominator is 9, so multiples of 9 close to 87 include 81 and 90. 90 is closer to 87 than 81. So we're going to use 90 instead. And then we get, after some of that, we get approximately 40. Over here, we have 51 and 6 over 11. Multiples of 11 that are close to 51 include 55 and 44. Now, in case you haven't noticed, those two and the ones over here aren't that, well, one of them's closer, yes, but it's not that big of a difference, which is why sometimes estimation can be very, very not good for your papers. But we're going to go with 55 because it's closer. Five times 6 equals to 30. Now, denominator is 5. 23. Multiples of 5 that are close to 23 include 25 and 20. 25 is closer to 23 than 20. Therefore, we are going to use 25. Which means that it's 2 over 5 times 25. And then you cross, and then you simplify, and then it's 5 divided by 5 equals to 1, and then 25 divided by 5 equals to 5, and then 2 times 5 equals to 10. So the answer to this one is approximately 10. It's actually closer to 9. So, over here, we have 7. And for this, we can have either 35 or 42. 42 is a slight bit closer. Therefore, we shall use 42. And then 42 divided by 7 equals to 6. 3 times 6 equals to 18. Approximately. Not the worst estimate I've seen. Definitely not the best, though. 42 times 7 over 15. Now 15, the closest multiple of 15 to 42 is 45. And then it'd be 3 times 7, which is equal to 21. Now we have 3 more questions until we move on to the actual multiplication of fractions. So, oh dear. The multiples of 7 that are close to 18 include 14 and 21. 21 is closer, therefore we are going to use 21. And then we get 6 times 3, which is equal to 18. Oh, 28 is a multiple of 4, so we just do it right like this. And then we get 3 times 7, which is 21. This is actually not an estimate. This is exact. Since we didn't really actually change the second factor. Now here we have 17 as a denominator and 35. A multiple of 17 is 34, which is really actually really close to 35. So we're going to use 34. Yay! Which means that we will end up with approximately 24. Now we're going to move on to actual multiplication. If you want to do some practice problems before that, or if you want to go to the bathroom, or if you want to do anything really and take a break, go right on ahead. I'm not going to stop you. If you don't want to take a break, or you just came back, well, here's multiplication of fractions. Yay! To multiply a fraction by a fraction, multiply the numerators and the denominators, then simplify the product. I.e., if we have, let's say, e over g times a over c, then it's just going to be e times a over g times c. That looks like a y. G times c. So then we have to simplify, of course, but we can't really simplify these numbers since, well, they're just random plug-in variables. So we're going to do some actual practice problems. Now, 8 over 17 times 2 over 3. How will we do this? Well, we decide to multiply the numerators together, 8 times 2, over 17 times 3. Multiply the denominators together, and we get 16 over 51. There are no common factors between 16 and 51. So, it is already written in the simplest form. Therefore, we don't need to simplify it. Now here, we have 3 over 10 times 4 over 5. We end up with 3 times 4 and 10 times 5, numerator to numerator, denominator to denominator, and then we get 12 over 50. We could simplify that, which gives us 6 over 25. Now here's one. 6 over 7 times 1 over 5. Multiply the numerators, 6 times 1, multiply the denominators, 7 times 5, and then we get 6 over 35. This is already in its simplest form, so we can't simplify it more. Now, we're going to do the next question. 5 over 8 times 1 over 2. And then we multiply the denominators together, and we multiply the numerators together, and we get 5 over 16. These don't have any common factors except 1. Therefore, they are already in their simplest form. Now, I'm going to teach you another method of, well, trying to avoid simplification. Here's the thing. You know how you simplify the numerator and the denominator by, well, dividing them by the same value? What if you divide them before you, well, multiply? Here's the thing. You can't simplify denominator to denominator because you simplify numerator to denominator. So, you look for common factors between, well, the numerator and the denominator diagonal from it. So 8 and 5. They don't have any common factors, so we just leave them alone. But 3 and 6 have a common factor, 3. So we divide both by their common factor, and 3 it becomes 1, and 6 becomes 2. Then we multiply. 1 times 5 over 8 times 2 equals to 5 over 16, which is in its simplest form. Now, if you want me to prove that this actually works, here's how you would do it without the previous simplification. 3 times 5 over 8 times 6 equals to 15 over 48. And then 15 and 48 share the factor of 3, and then you divide, and then it becomes 15 divided by 3 equals to 5. 48 divided by 3 equals to 16. So yeah. Now we're going to try it on question number 6. And we end up with 9 and 4 don't share anything, and 10 and 3 don't share anything either. So, we just multiply. And we end up with 27 over 40, which is also already in its simplest form. Here's the thing though, if you want to do it in the crisscross way, you need to make sure that everything's already in its simplest form. Because if this was 18 over 20, or actually no, not 18 over 20, because then 4 would crisscross work in the crisscross. 45 over 50, there's no common factors, but you're still going to end up having to simplify it because 45 and 50 are not in its simplest terms or forms. Now, over here, we have 7, 9, don't share anything. 7 over 12 and 8 over 9 are both in its simplest form. And then 12 and 8 share something. The common factor is 4, by the way. Greatest common factor. So we divide by 4 and we end up with 2 and 3. And then we get 7 times 2 over 3 times 9 equals to 14 over 27. These do not share any common factors. The last question, 1 over 9 is in its simplest form. 3 over 7 is also in its simplest form. So we do the crisscross. 1 and 7 don't have anything in common, but 3 and 9 do. And the greatest common factor is 3. So 3 divided by 3 is equal to 1. 9 divided by 3 is equal to 3. So we end up with 1 times 1 on the top, and 3 times 7 on the bottom, and we end up with 1 over 21, which is in its simplest form. So if you want to do some practice problems and take a break, go ahead. If you don't, or you came back, we're going to continue on with multiplying with mixed numbers. Now how would you do that? How would you go about doing that? Well, you would convert the mixed numbers, and not into Christianity or religion, but into improper fractions. Did you get the pun? Anyhow, so if you multiply 8 and 3/7 with 3 and 2/3, then you need to convert them all into improper fractions, and you end up with blah blah blah. 8 times 7 equals to 56. 56 plus 3 is the new numerator. 56 plus 3 is 59 over 7, and then we would end up with times 3 times 3 is equal to 9. 9 plus 2 is the new numerator, which is 11, and then the old denominator. Okay. And then we have 7 and 11 do not share anything. 59 and 3 also don't share anything. So we end up with 59 times 11 is 649. Yeah. These numbers over here don't share any common factors. So, it's already as simplified as much as possible. You can, however, convert this back into a mixed number, and you would end up with 6 Okay. 30 and 19 over 21. Yeah. That's your answer as an improper fraction, and that's your answer as a mixed number. So we're going to do a few practice problems. Now the first one, 6 and 7/10 can be converted into 6 times 10 equals to 60, 60 plus 7 equals to 67. Done. Times 1 and 1/4 is 1 times 4, 4 plus 1, 5, 5 over 4. And then we do the crisscross. 67 and 4 don't really share anything, but 10 and 5 do. They share a common factor, greatest common factor of 5. And 5 divided by 5 is 1, 10 divided by 5 is 2. And then we multiply, and it becomes 67 times 1 over 2 times 4, which then becomes 67 over 8. Okay. If you want this to be a mixed number, then it'd be 8 and 3/8. Now we move on to the second and third questions. The second question is 4 and 7 over 15. Then to convert that into an improper fraction, 4 times 15 equals to 60. 60 plus 7 equals to 67 again. Okay. And then it's times 2 times 6 is 12. 12 plus 5 is 17 over 6. You do the crisscross, nothing shares anything. So you just end up with 15 times 6 and 67 times 17. 15 times 6 is equal to 75, by the way. What's 67 times 17, though? Okay. There. If you want this to be a mixed number, then we do some division. We end up with oh dear. This is gonna be a blast. Yeah, try not to have your equations intruding on each other. Okay. 15 and 14 over 75. Yeah. Now, the last question of this section is 6 and 5/7 times 2 and 7/8. So 6 times 7, 42, 42 plus 5. Oh, 47, that's prime. Quite sure that's prime. Ugh, prime numbers. I mean, prime numbers are great and all, but sometimes they're just, well, no. Yeah, nothing shares anything. So we end up with 47 times 23 and over 7 times 8, which is something over 56. And that something is going to be found out right now with some good old multiplication. That's a 0, by the way. Okay. 1081 over 56. If you want that to be a mixed number, then that would be Actually, no, you don't need decimals for this. It's just remainders. Thing is, in higher grades, you don't actually use mixed numbers that much. It's mostly improper fractions. So yeah, you end up not being used to having remainders because usually they ask for decimals or improper fractions, and they almost never ask for mixed numbers. So anyhow, we're going to move on to division. So dividing a fraction is very similar to multiplying, except you're multiplying by the reciprocal of the divisor, or the second number in the division equation. So, to divide 6 over 11 by 3 over 7, step 1, find reciprocal of divisor, i.e. second number. So what is a reciprocal? It's basically where you flip the numerator and denominator. So the reciprocal of the divisor, the second number, is, well, you flip 3 and 7. So the reciprocal would be 7 over 3. Step 2, you use the reciprocal, and then you actually multiply. Yes, guys, you multiply by the reciprocal. After you find the reciprocal, you change the division sign into a multiplication sign, and then you continue on as if nothing has happened. Now we do the crisscross, and then there's 2. And then it would be 2 times 7 equals, well, that's 14. 13 over 11 times 1, which is just 11. Now step 3 would usually be to simplify. But if you use the crisscross method, you don't actually really need to simplify because you already did the simplification. But hey. Anyhow, divide 3 over 8 by 4. So step 1, find the reciprocal of the divisor, which is 4. Now what's the reciprocal of 4? There is not really any denominator, but there is. Well, the denominator for whole numbers is 1. So 4 as a fraction would be 4 over 1. And if we flip that, it would become 1 over 4. Step 2, we actually put that in. If you guys don't know, a dot, a filled dot, is actually another sign for multiplication, but you don't really use that in younger grades. Then you get 3 times 1, 8 times 4, and that becomes 3 over 32, which you can't really simplify, so now we're going to do some good old practice problems. 8 over 11 divided by 4 over 7. So 4 over 7, the reciprocal of 4 over 7, you trade well, how would you say this? You switch the places around? You make them trade each other's places? Oh, okay. Just, you get the point. It's not equals to, so becomes. Yeah, that's a better. That's better. And then you plug it in, get multiplied by this, and then you do the crisscross simplification. You end up with 2 times 7 over 11 times 1, which then becomes 14 over 11, which is already simplified. Now here we have 2 over 3 and 4 over 5. 4 over 5 is a divisor, and then we switch around the places of the numerator and denominator and find the reciprocal. Then we make the division sign into a multiplication sign and do the crisscross simplification, which is what I call it. And you just multiply like normal, and you get 5/6, which is as simplified as it gets. We move on to the next two problems, which are also the last two problems of this section. Now, oh, this is another one with 4. Okay. So we already know that the reciprocal of 4 is 1/4. Times, because the division now turns into a times symbol. And, oh, okay. So if we cross simplify, we just get 1 and 1 over here. And that would mean that it's 1 times 1 over 9 times 1, which is just 1 over 9, which is as simplified as it gets. Now here, this is the interesting part. So the divisor is 3/8. And we find the reciprocal. And we get 8/3. We plug in the reciprocal, and we get 6 times 8/3. Now how would this work? Well, 6 is just 6/1. So if you multiply the numerators together, it's 6 times 8. And then 1 times 3. And we didn't really cross simplify, so we're going to have to do step 3. Step 3 is for when you forget. A. And then we end up with 48/3, which simplifies to just, well, 16. Just 16. Because 3 divided by 3 is 1, and then 48 divided by 3 is 16, and 16/1 just equals to 16. So we're going to move on to the next section, which is dividing mixed numbers. It's the same general idea. You convert into improper fractions. Find and multiply by reciprocal of divisor and simplify. If you didn't do the crisscross simplification. Now, let's do it with this question. Convert into improper fractions. 6x and 2/7. 6 times 7 is 42. 42 plus 2 is 44. So that'd be 44/7. And then it'd be divided by 3 and 2/5. 3 times 5 equals to 15. 15 plus 2 equals to 17. 17/5. And then you find the reciprocal of the divisor, which is just, hang on, let me get the dividend. The reciprocal of the divisor is 5/17, and then you multiply. So that's 220 over 7 times 17 is equal to 119. That's as simplified as it gets, guys. So now, we're going to do some practice problems. Some of them have mixed numbers, some of them don't, some of them have whole numbers, some of them don't. So over here, think of this as a mega compilation of everything. that we learned about dividing fractions. So 2 over 9, 5 over 6, nothing's a mixed number. We don't need to convert into improper fractions. So then we just find the reciprocal. 5 over 6, reciprocal of that is 6 over 5. And then we multiply and get, well, okay, let's cross simplify first. The common factor is 3, greatest common factor is 3. So then that'd be, then 2 times 2 over 3 times 5 equals to 4 over 15. It's as simplified as it gets. Now, we move on. Oh, this is interesting. So, 1 over 4. If you find the reciprocal of 1 over 4, it's just going to be 4 over 1, or, well, 4. But we're going to keep it as 4 over 1, because that's, well, more convenient for what we're doing right now. Times 4 over 1, cross simplify, and then we get 7 times 2 over 5 times 1 equals to 14 over 5. Twelve and 4/5 divided by 4 is, well, we find the reciprocal of 4, which is 1 over 4, and then we convert 12 and 4/5 into a improper fraction because that's a mixed number, and 12 times 5 equals to 60. 60 plus 4 is 64, and then it's 5. Now we move on to the actual multiplication bit, since we've already found the reciprocal and converted. We're going to cross simplify, and then we get 16. 16 times 1 over 5 times 1 equals to 16 over 5. And that's as simplified as it gets. We continue. 71 divided by 5 and 3/4. Okay. So 5 and 3/4 is our divisor, which means that we will need to convert this into an improper fraction, and then we need to find the reciprocal of that improper fraction. So this into an improper fraction would be 5 times 4, 20. 20 plus 3 is equal to 23. 23 over 4, and then we find the reciprocal, which is 4 over 23. And we get 71 times 4 over 23, which is, well, like this. And we can't really cross simplify for this, so and then that is and that's it for that question, at least. Over here it's a similar type question, except instead of 5 and 3 over 4, it's 5 and 3 over 5. Which converts to 5 times 5, 28 over 5, which reciprocates, yeah, into 5 and over 28, okay. I haven't seen many things over 28, just saying. That'd be 16 over 1 times 5 over 28, and then we cross simplify. The greatest common factor is 4, and we get this, which results in 4 times 5 over 1 times 7 equals to 20 and over 7. 20 over 7 is as simplified as it gets. 5 and 4/9 divided by 1/3. So we need to find and convert the mixed numbers into improper fractions. 5 and 4 over 9 is equal to 5 times 9 is equal to 45. 45 plus 4 is equal to 49. 49 over 9. And then 1 over 3 is, well, reciprocated into 3 over 1, which is just 3, which means that we end up with 49 over 9 times 3 over 1. Seems about right. We cross simplify, and we end up with, okay, it's 1 over 1. 1 over 1 is just 1. You could just ignore that. We just end up with 49 over 3. In case you haven't noticed, we don't really have that much space over here, so I'm just gonna circle the answers instead now. We continue, and continuing. So for this one, and the next few, we actually need to convert everything into improper fractions first. So 3 and 2/7, 3 times 7, 21. 21 plus 2 is 23 over 7. And then over here it's 4 and 2/3. 4 times 3 is equal to 12. 12 plus 2 is equal to 14. And then we reciprocate this thing, and we get 3 over 14. We end up with 23 over 7 times 3 over 14. We can't actually cross simplify here, so we end up with 23 times 3 over 7 times 14, and that is equal to 69 over 98. That's as simplified as it gets. We're going to convert these into improper fractions too, because they're both mixed numbers. Oh dear. 6 and 3 over 7. 6 times 7, 42. 42 plus 3, 45 over 7. Over here it's 8 times 7 is 56. 56 plus 6 is 65. 65 over 7. And then you reciprocate it and you get 7 over 65. And we end up with 45 over 7 times 7 over 62. And then we cross, and we can't really cross these two because they don't have anything in common. And we end up with, well, there's 1 over here and 1 over here. We're just going to end up with 45 over 62. We continue. And there's 2 mixed numbers over here, so I'm going to convert those into improper fractions. 6 times 12 is equal to, 72. 72 plus 5, 77. 77 over 12. 3 times 4 is equal to 12. 12 plus 1, 13. 13 over 4. And then 13 over 4, we reciprocate 13 over 4. And then we get 4 over 13. We end up with 77 over 12 times 4 over 13. Now we realize that we can cross simplify these two, and this would be 1 and 3. 77 times 1 over 3 times 13 equals to 77 over 39. That's it for that question. And we're on the last question of the section and of the chapter. Not time to slack off yet, but hooray. 3 times 2, these are both mixed numbers, so you have to convert them. 3 times 2 is 6, 6 plus 1, 7, 7 over 2, 3 times 10, 33 over 10, And then you have to reciprocate the divisor, and that's 10 over 33. And then we end up with 7 over 2 times 10 over 33. And you could cross simplify over here. And then we end up with 7 times 5 over 1 times 33. And that is 35 over 33. So we're done the chapter. We're done the section. We're done the last question. I.e., we're done the chapter, which I already said at the beginning. So I guess I'll be seeing you in the next chapter.